Well, good afternoon, everyone. I'm Ryan Siegel. I'm joined by my colleague Brian Tillman from the 360 Energy Group this afternoon. Today's session will be approximately an hour and a half long. So for those of you who are maybe new to our interface, there are controls. If you scroll move your mouse towards the top or bottom of your screen, you should be able to have a little pop-up there where you can go ahead and use the question and answer feature. So if you do have any questions during today's session, please go ahead and use that function. We will go ahead and answer questions during the presentation or at the end. So if you do have any questions, please do go ahead and use that question and answer function. If you do place them in the chat, we may or may not see them. We're also going to make sure that we capture those questions and make sure we do get those answered if we don't answer them today. As far as today's presentation, it is being recorded and will be posted to our website at SEDAC.org. Certificates of attendance for today's presentation will be sent out to participants approximately here within the week. For those of you who may be ICC or AIA members, when we send out those certificates, you can go ahead and reply back, and we will go ahead and with your AIA or ICC member number, and we'll go ahead and get those reported in for you. But again, all attendees will get a certificate for today. So as far as some of our learning objectives and what we're going to be covering today is the new City of Chicago EVSE, or Electric Vehicle Supply Equipment, more colloquially known as a charger. Their new ordinance requirements, some of the differences between EVSE ready and EVSE installed, and also the differences in the various levels of charging that are available out there. So real briefly, as far as who we are, part of the Smart Energy Design Assistance Center, or SEDAC. We're housed at the University of Illinois, and we're also a public-private partnership with our private partner, 360 Energy Group, of which, as I noted, Brian Tillman is part of. So, and our overall mission is to reduce the energy footprint across the state of Illinois and now beyond. These trainings are one of the ways that we do that. So with a little bit of background about who we are, I'd like to learn a little bit more about who you are today. So go ahead and set out a poll here. First, what would you classify yourself as? Architect, engineer, building owner, code official, other energy professional, or none of the above. Second is if you own an electric vehicle, be it a plug-in hybrid, a range extended electric, or a battery electric. And then third is within 10 years, what's the probability you foresee your household will own an electric vehicle? So you may have to scroll to see all three questions here. Looks like most everyone has voted here, so we'll go ahead and let's see who we have here today. Looks like mostly architects and engineers with a smattering of other people. The majority of people do not. Interesting, we do have almost 10% of the people do already have electric vehicles, so that's interesting to see. And somewhere around half believe here within the next 10 years they'll likely have one. Several people saying they will definitely have one. So very interesting. So it'll be interesting to see how that compares with some of the national trends out there. So Just for everyone's information, we are the energy conservation, the Illinois Energy Conservation Code training provider, made possible in part by the Illinois Environmental Protection Agency and the Illinois State Energy Office. So we do want to thank them for their support. And today's session, we've partnered with the City of Chicago, and we do want to thank them for inviting us to provide today's training session. So as far as if people out there that may have questions regarding the energy code, you can feel free to reach out to us. We have a technical support system that you can go ahead and ask your questions through, energycode@sedac.org. Doesn't necessarily have to be code officials or architects or engineers. We do get several questions through our technical support line, even from building owners and occupants and other people who are dealing in construction. So that is available for anyone who may need assistance with the Illinois Energy Code. Again, energycode@sedac.org. We also do have an 800 number, as well as many online resources at our website. Again, sedac.org/energy-code. Some of those resources include archives of previous workshops and webinars. So that is also where you will find a recording of today's session afterwards. We also have several online on-demand training modules. These modules are designed for more of a beginner audience, so you don't need to have code knowledge in order to get use out of these training modules. So those can be very useful. So as far as City of Chicago, they've really stepped up and kind of moved ahead of the national trend here, and we'll talk a little bit more about that in a little bit later. But the City of Chicago is really looking to get ahead as far as the electric vehicles. They are coming, and so the more that we can prepare, it's going to be a much lower cost to prepare for them earlier rather than having to do a lot more in the way of retrofitting. So that's kind of the national trend. As I recall, we said about 10% of our audience today have electric vehicles. So that's actually a little ahead of the trend. Here this was done a study a few years ago by Bloomberg, and by 2020, they're projecting, just a few percent of people would have them. So that's good to see that Chicago seems to be headed in the right direction here. So as far as the EV ready and ordinances that were recently passed and recently adopted, this was adopted back in April, which I realize seems so long ago, but something that this covers is these amended the parking requirements. In particular, this is in the zoning requirements for the City of Chicago. So again, with that being in the zoning ordinance, may be a little easy to miss. Should also make a note that the code, the online code, does not appear to presently reflect the amendments that were made. And so one way to tell if you are looking at the most current version is the older version had an enforcement date of July 31st. The new is an October 31st deadline. And so something that you may have caught from the title slide is this is effective for permits that were applied for beginning November 1st. And so what that is defined as is a permit application is started once you've provided the $300 deposit and the applicable zoning fee paid through the City of Chicago's online portal. So applying for the permit does include making sure that you've paid for that as well. So A couple of definitions that we'll talk about. One of these is EVSE capable. This is not found in the City of Chicago's ordinance because they don't require capable. They require the two higher levels that we'll talk about momentarily. But the City of Chicago has taken a step forward just slightly from the rest of the country and even the state of Illinois by adopting this a little bit ahead. And this is coming in the upcoming edition of the 2021 International Energy Conservation Code. That is actually going to be published here next month with adoption and enforcement beginning in the state of Illinois sometime around late spring of 2022. So somewhere around 18 to 20 months from now, this will be enforced for the state of Illinois. With capable, what this requires is you have to have your panel capacity and your panel space, including making sure that you have labeled, EV, future EV charger or something of that nature, along with a raceway for that future wire to be pulled through. And this requires a 40 amp, either 208 or 240 volt circuit as applicable. So what this looks like is for every 2 circuits, you're probably going to need about a 1-inch conduit in order to bring 2 EVSE circuits through that. So capable, again, we need panel capacity, panel space, and the raceway for a future pull of wire for that 40 amp circuit. Now the next level is EVSE ready. So what this is you've got your raceway, your panel space, and your breaker capacity. Now for EVSE ready, we need to add to that our wire in the raceway and likely our breaker at the front end too. So that way you're all ready to go when you're ready to go to the next level. And the other end of that wire terminates at either a receptacle, junction box, or a piece of equipment that's adjacent to the parking space. So what's depicted here would definitely be one common method for termination and just having the receptacle there. This definitely makes the next stage a whole lot easier to achieve. So once we've gotten through capable and we've gotten through ready, which includes our wire, finally we have EVSE installed. So now that we've got our raceway and our wire installed, the final step is actually install your charging station. So here in the picture, you can see this one is actually hardwired down here where you can see that junction box. So, whereas if you terminate in a receptacle for EV ready, you can purchase a charger that just plugs right in. So it makes things a little simpler for you. As far as the code requirements, so at what point do you need to have these things? So for the City of Chicago, for any multi-unit residential building, the trigger here is you have to have at least 5 or more dwelling units. That's where you are going to be required to have either EVSE ready or installed. So they do use that interchangeably throughout a lot of this. And so at least 20% of the parking spaces need to have EVSE ready or installed. So previously, again, noted some of this is still floating out there on the web. Previously, you just had to have 2 ready parking spaces if you had a building of 24 or more. So this lowered the number of dwelling units from 24 down to 5. So many more properties will be subject to this, and increasing from just 2 parking spaces up to 20% of the parking. Brian will talk a little bit more about how building owners will be able to extend that 20% capacity much further. So we'll talk a little bit more about that later. So for the rest of the state that's going to be adopting the 2021 IECC here before long, there is a little bit lower, where rather than here, you have to have at least 20% EVSE ready or installed. The IECC is going to call for it to be capable. So one tier below. Got to have your raceway, and you got to have your breaker space for that, and the load capacity. So for those smaller buildings, you're going to have at least 2 EVSE ready spaces if you have more than 2 dwelling units. And for the small buildings, you'll have to have 1 EVSE ready per dwelling unit for single and multifamily. So, as far as non-residential buildings, here the trigger is going to be once you have 30 or more parking spaces, then you need at least 20% of the parking spaces have to be EVSE ready or installed. So whereas residential, we needed 5 dwelling units. For commercial, if you have at least 30 parking spaces. And these, again, the IECC is going to be 20% EVSE capable, and 2 have to be ready. So if you're in the city, you're going to have to need at least 20% ready. If you're outside of the city, you're going to have at least 2 parking spaces ready. So again, the difference between capable and ready being, did you pull the wire or not? So you'll still have to run all the conduit for at least 20% of the parking spaces, regardless of if you're in the city of Chicago or outside. So, accessible parking, realize accessible parking can be quite a challenge. And so as part of this, they do have a table as far as how many of the EV ready parking spaces need to be located in accessible parking spaces. So not terribly difficult or arduous, but being aware that some of the EV parking spaces do need to be in accessible parking spaces. Now the code does state that a non-EV vehicle with the appropriate handicap parking decal or placards may still use the EV parking spaces for the accessible parking. So we don't want to detract from the ability of people who need accessible parking to use that. So with this, we're on track to prepare for electric vehicles. So City of Chicago is good in getting prepared. So before I transition over to Brian Tillman, let me go ahead and launch another poll here and talk and make sure we covered what we needed to. So the first poll question being, what are the requirements of installation of EVSE, or what requires the installation of EVSE infrastructure? The Chicago Electrical Code, Chicago Zoning Code, Chicago Building Code, or I don't know. Second is, what is required for a space to be EVSE ready? You can choose more than one here. Non-metallic cable, or Romex. Raceway, also typically called conduit. Wire, vehicle charger, an electric vehicle, or none of these. And third is, what is the threshold to install EVSE ready or installed spaces for non-residential buildings? 40 parking spaces, 30, 20, 10, or 1 parking space. So a few questions coming in here. One of which is for existing buildings, and under the City of Chicago's code. This, I believe, verify, this covers new construction. Yeah, this is new construction of multi-unit residential or non-residential. So this would not be requiring retrofits, but Brian will talk a little bit more about how retrofits can be beneficial and perhaps attract new tenants for buildings. So, have a question here as far as load sharing technology and reducing, does that enable a building owner to reduce that 20%? And as written, this is 20% of the parking spaces need to be EV ready, and so that means 20% of the spaces need to be supplied by a 40 amp circuit. Now, Brian will talk a little bit more about that load sharing technology and how that will enable, because as we saw earlier, more and more people will have electric vehicles into the future. And so some of that load sharing technology can allow you to extend that 20% to cover, much more, many more spaces than that 20%. So yeah, you will have to make sure to bring the power to at least 20%. So. Again, just to reiterate, the effective date is for permits that are applied and paid for beginning after October 31st, also known as November 1st of 2020. So that is coming up real soon. So, looks like we got most everyone in to vote here. So most people picked up on, yes, it is the zoning code, which is where you find the requirements for EVSE infrastructure. So good, we did pick up on that. EVSE ready. Did have a few people that said Romex, not in the city of Chicago, but EVSE ready. Yes, we do need to have our conduit. We do need to have our wire. So those are the two things that we need to have. Vehicle charger is not required. That would be for EVSE installed. Don't need our electric vehicle. So, as far as our threshold for non-residential, most people picked up, yes, it is 30 parking spaces. So once you have at least 30, then you need to be sure that you're providing that EVSE infrastructure. So pretty good. So, with that, I'm going to turn it over to my colleague, Brian Tillman.
Great. Thank you so much, Ryan. Can you hear me okay?
Yes.
Perfect. Thank you very much for the introduction. I'm going to go ahead and give a brief overview of electric vehicles, start with a brief overview of electric vehicles and some of the charge stations. So to begin our conversation, I just want to give a high-level overview of what an electric vehicle is. A lot of times we think about an electric vehicle as just the purely electric vehicles which are shown on the right here. Those could be the Chevy Bolt or the Tesla Model 3. But really we want to think about all electric vehicles, which starts all the way on the left here with hybrid electric vehicles. Those are, kind of the vehicles that many of us have been driving for years, like a Toyota Prius. Those are vehicles that don't necessarily plug into the wall, but they do use some electricity for propulsion. As you kind of go through this continuum, you'll have vehicles that can plug in, like a plug-in hybrid or range extended electric vehicle, which typically get a certain number of miles all electric, and then they move into having gasoline as a backup. Those vehicles may get 30 to say 50 miles all electric, sometimes more, sometimes less than that, but that's pretty common for those types of vehicles. But those two also plug in. So, really when we're thinking about where the charge stations would be used for, we'd think about the plug-in hybrids, the range extended electric vehicles, and your full electric vehicles that do not have a gas backup. With that, when you're planning for electric vehicle charge stations, sometimes this can be beneficial to if you know who your users might be. They have different charging habits, so plug-in hybrid or range extended electric vehicle may charge more frequently, but for shorter amounts of time, whereas a full electric vehicle may be charging because they have larger batteries, may be charging for longer amounts of time, but for not quite as frequently. So as we move forward into the next slide, we're going to be looking at kind of the charge stations themselves. And I won't go into too much detail here, but I want to give a quick overview of what a level 1 is and what a DC fast charger is. We're going to be focusing most of our time on the level 2 charge stations. That's why we are here today. But level 1 charge station is essentially plugging into your typical 120 volt outlet. You do see if you had a typical electric vehicle, if you were to do this, your car would get typically 2 to 5 miles of range for every hour that this vehicle is plugged in for. So even if you're getting 5 miles of range per hour, you may get, if over 12 hours, you may get 60 miles of range. So some people do use this for home or for workplaces, but a lot of people use the second option here, the level 2 for homes and workplaces. These are your 208 and 240 volt. It provides power for somewhere between 10 and 50 miles of range for every hour that it's plugged in. We'll go into a little bit more detail about how fast these charge stations do charge vehicles shortly, but just as a very quick overview, these are the charge stations that people will typically use for overnight charging, or even to plug in if they're at a grocery store or workplace or a lot of other buildings. And this is what we're going to be focusing our conversation on today. The third charging option is the DCFC, also known as the DC fast charger. These charge stations they charge very quickly. You can get typically 150 to about 1,000 miles of range per hour that you're plugged in. They're for quick fill-ups. You do see these sometimes in cities, but typically you see these along highways. They're really for somebody that wants to plug in, charge up, and get on their way. So as I mentioned, there are different amp capacities for the different charge stations. As we start to look at this, we want to show how this can affect charging. The chart on this page shows how fast the vehicle can charge with different capacities. So, you can, as an example, if you were to charge at with a 40 amp circuit breaker, that means that the maximum output for the charge station would be 32 amps, and that would provide the vehicle about 6.6 kilowatts of power per hour that you're plugged in. On a typical vehicle, if you're getting about 3 miles per kilowatt hour, you're getting about 20 miles of range. And vehicles do have different levels of efficiency. So as an example, I have an electric vehicle. My electric vehicle actually gets about 4 miles of range for every kilowatt. So in that case, I might be getting closer to 25 miles of range for every hour that I'm plugged in. And this just gives you, but this chart gives you an example of what a typical vehicle would get. Larger vehicles or less efficient vehicles may get a little bit below that 20 miles of range. More efficient vehicles may get a little bit above that. This is just to give you a good idea of how much range could be added to the car for every hour that you're plugged in.
Something else that, just to jump in there, the requirement for the city of Chicago is a 40 amp circuit breaker. It may not be a bad idea, and what part of this is identifying that vehicle chargers out there that we've seen can take anywhere from 40 amps all the way up to a 100 amp breaker. So it may not be unwise to perhaps consider oversizing some of the conduit and infrastructure like that if a building looks at and may want to choose to use a higher ampacity charger going into the future. So just something to consider.
Yeah, and to your point, as vehicles get larger batteries and are used in different ways, there has been kind of an emphasis in the market to continue to provide, faster charging. that has been a little bit of a trend here. Now we just want to start in and talk about there's different types of electric vehicle chargers. There's non-connected chargers. This means that you just pull up, you plug in, and the charger is not necessarily connected to the internet, and you can just simply charge when you plug in. Now, sometimes vehicles do have the ability, they've got some intelligence built into them, so if you want to plug into one of these charge stations, but maybe you didn't want to start charging right away, you wanted to charge at midnight, you can't, there might be some intelligence in the vehicle, but there wouldn't necessarily be that in the charge station. Then you have other charge stations that are Wi-Fi or cellular connected, and you can often set these up for remote notifications. Sometimes these charge stations could be reserved in advance if somebody needed to do that. There's also the ability to take payment with many of these charge stations. One thing to note, sometimes there are network fees associated with this. So it's just something as you're looking and exploring different charge stations, it is important to understand what the benefits are, but also, that there could be, networking fees or other pieces associated with that. There's also options for power share. This was mentioned a little bit earlier. This allows somebody to connect to one circuit and run more than one charge station on that circuit. This strategy really helps allow people to stretch at infrastructure investment. Actually, at the garage that I park in for work, or typically park in for work, I can plug in. When I plug into that charge station, I typically get about 40 miles of charge for every hour that I'm plugged in, but that's if I'm the only one plugged in there. Now, if another car pulls up next to me and plugs in, now we're sharing that power, and we're each getting about 24 miles of range for every hour that we're plugged in. Now, if all 4 spaces were plugged in, we see that go down to about 12 miles of range for every hour that we're plugged in. It works great for workplace charging, and it's been really beneficial to us because everyone kind of has that charger that they can plug into. And if somebody gets there earlier, if somebody leaves, and the others are still plugged in, you do have that power that kind of goes up and down in accordance to how many people are there. It is a system that works very nicely. And then the last thing I just wanted to mention on here is there are various cord lengths, and that's another thing sometimes people may want to consider. And we'll talk about this in the case studies later, but sometimes having a longer cord length allows you to plug in into multiple different parking spaces. So at the building that I used to live in, we had one charge station that was shared among multiple different users. So we could, if my neighbor wasn't plugged in, I could go ahead and plug my vehicle in, but if they needed to charge, they could stretch that cord into their parking space as well. So just a couple of different things to consider when you're thinking about different charge stations. The next thing we want to lightly mention is that if you do end up installing a charge station, you may be interested in learning how you can recuperate the cost for electricity. So there's a couple different payment methods. Some charge stations take credit card, some use an RFID card, and others recognize, your car once you pull up. It's got kind of intelligence to recognize that this is Brian's car or Ryan's car, and it'll actually bill you electronically for that electricity that you used. We have seen some buildings charge a monthly fee. To anyone that pays that fee gets charged at that station. We've also seen some sub-metering where a building will simply add the cost to the homeowners association fees, or if you're an office tenant, to kind of that office tenant. So once you know how you'll bill the customer, it's important to know if you'll bill them for every hour that they're plugged in or for every kilowatt hour. So sometimes people will want to bill on a kilowatt hour basis and just recuperate the amount for the electricity, while others will want to bill on an hourly basis. And in some cases, people want to bill on an hourly basis where maybe they say for the first 3 hours that somebody arrives and starts charging, maybe we're going to charge a certain rate or maybe even give the electricity away for free. But after 3 hours, we want them to, we don't want them all there all day. So we want them to move their car. We want them to pay a little bit more for the electricity. And we've seen that in certain instances where maybe a restaurant doesn't want somebody there for more than 3 hours. Now let's move on. We'll talk a little bit about ownership models. These are several of the ownership models that we have seen in different buildings, and we want to provide some insight into what might be seen at various buildings, or as people are thinking about what they might want to do at their building, they can look at these models and see if any of them make sense for them. The first one is where an occupant or a tenant owns the charge station. This is fairly common in buildings where the occupant or tenant owns their parking space and adds a charge station to the space. There are different ways to cover the cost for electricity, including submetering and charging for the electricity, or just charging a monthly fee. The next model that we see fairly frequently is where a building or a homeowner association owns the charge station and allows the tenants to use the station. So you might see that in an apartment building or a condo building where somebody where the building will actually own that charge station and then just charge for the kilowatt hours that are used, or charge on a monthly basis if that's easier. The last ownership model that we'll discuss today is where a building outsources the charge station ownership. Sometimes an EV management company charges a fee, or sometimes there's another value stream such as advertising on the charge station that covers the cost of the charge station. In Chicago, we've seen that at a number of different grocery stores where a charge station is put on the property, and then there's an advertising board up front that is essentially how that charge station owner generates their revenue to cover the cost for the charge station. So there's a couple different models that could be looked into, and I think it's worthwhile examining which one makes the most sense for your building. Now let's talk a little bit about why we are seeing the push for this transition to electric vehicles. So as we think about the benefits to society, we'll start by mentioning that electric vehicles are use considerably less energy than an internal combustion engine vehicle or their internal combustion engine vehicle counterparts. Electric vehicles often use 75 to 80% less energy. We also know that if Illinois were to transition about 2/3 of their vehicles to electric, the state could save about $3 billion annually due to a reduction in human health impacts and other associated climate impacts. This number could reach actually over $4 billion if we were to move to clean energy. We also see that electric vehicles are flexible loads since they can typically charge anytime. This can be beneficial to the grid since there are ways to encourage people to charge during off-peak demand times. We'll talk a little bit more about that shortly, but I just want to bring that up as an immediate benefit. There are also more ways to integrate the vehicle into the grid. There's vehicle-to-grid capabilities where potentially a vehicle could push power back into the grid, or ways to integrate renewable energy with the grid by leveraging the battery within the electric vehicle. This is probably a little bit forward-looking, so we're not going to talk too much about that today because we're seeing pilots and we're seeing other projects happen around that, but we have not seen a lot of that happening today. But I just want to at least lightly mention that. On the last slide, we did talk about some of the grid benefits. I want to kind of expand a little further. When we talk about capacity utilization, we are talking about the use of existing established infrastructure to supply fuel. We already have the grid, so implementing managed charging strategies where we're encouraging people to charge at night can actually be a strategy that lowers electricity costs for everybody. The grid is there. If we get people to start charging at night when there's excess capacity on the grid, it is a way that we can actually lower costs for all of electricity users. And then the other piece to this is energy independence. So currently we import a lot of oil and gas, whereas shifting to electricity would help us move towards more locally produced energy. So that could help us from an energy independence standpoint. Now we're going to start to talk about how the transition to electric vehicles can benefit the vehicle owners themselves. So the first thing that we want to talk about, and at the very top of the slide here, is how much does it cost? I think a lot of people are interested in saving money. So this slide provides an example of the fuel savings that can be achieved by moving to an electric vehicle. As you can see here, the more miles you drive, so as you go from 12,000 miles to 15 to 18 to even 30,000 miles, you will see a greater dollar savings going from, say, a Toyota Camry or to, say, a Tesla Model 3. So the more miles that you drive, the more you save. And we'll talk about this in a minute, but beyond just the fuel savings, there are more and more studies that are coming out showing that maintenance can have a pretty big savings when you transition to an electric vehicle.
And something to note on there is that electricity rate that was assumed there was 20 cents a kilowatt hour. So, I mean, the savings are dramatic even at that fairly high electricity rate. Probably more typical for, that might be more typical when you are at a remote charger, say at work or something like that. But if you were at home charging, that might be closer to 10 cents or even less. So this cost of fuel could be half of this or even less, depending on where you're charging. But we wanted to make sure that we were conservative and said, you know, okay, even if you don't do any charging at home and you had to pay 20 cents a kilowatt hour, there's still significant savings here.
Great point, Ryan. And I wanted, in fact, I just noticed that somebody had mentioned something on the Q&A mentioning that real-time pricing can be very beneficial as well. So this is, you know, time of use pricing. So when we're talking about 20 cents a kilowatt hour, but the fact that, you know, typically in Chicago we're paying less than that. To add to that, if you were to move to time of use pricing, and if you were to schedule your car to charge, so our cars are flexible loads. You know, as an example, if your car gets 300 miles of range, but you only drive it 50 miles a day, you're typically not going to need to charge it immediately. You can kind of, when you get home, you can plug it in and know that, hey, maybe you want it filled back up for the morning, but you don't necessarily need to charge it right away. You've got enough charge in there just in case you needed to run out that evening for something. But typically people will schedule their vehicle to charge. So I typically am scheduling my vehicle to charge at 1, 2, or 3 a.m., which you can see from this chart is when electricity prices usually are the lowest. And so there's actually additional savings that can be had by charging at that time. So it benefits me, but it also actually, because you're using this electricity that typically wouldn't be used at 3 a.m., benefits other ratepayers as well, other ratepayers that are paying for the electricity. So as we go over some of the benefits to the owner, I want to also mention a few more items. I mentioned this earlier, but electric vehicles often do have lower maintenance costs. There was actually a recent study showing that it was about half the cost for maintenance over several years. So, you know, again, electric vehicles have not been around that many years. So a lot of these studies, a lot of this data is really starting to come in, and with, you know, electric vehicles evolving, you know, you're seeing that continue to evolve as well. But we are seeing that, generally speaking, maintenance costs are lower, and that makes sense. There's fewer moving parts. The next piece, and this is something that I don't know, a lot of times people that don't have electric vehicles don't necessarily see the value in this as much as some of us that do have electric vehicles, but every morning you wake up with a full tank of gas, or full tank of fuel, I should say. There isn't that need to stop on your way to work in the morning. There isn't the need to stop when it's raining out. You wake up every morning, you're fully fueled. Unless you're going on a long trip somewhere, you're pretty much set to go for the day. The next item here is that EVs are expected to hit cost parity by 2025. This is when essentially electric vehicles are the same cost as their gas counterparts. Now, it could probably be argued that some cars are already at cost parity, but I think most experts really feel that it'll be more holistic throughout the market by 2025. So we'll see a lot of different vehicle options, and that a lot of these will start to hit cost parity by 2025. I also believe that this is when we'll really see the adoption rates increase for electric vehicles, because once these vehicles are at the same cost, you're going to see more and more people wanting to purchase these vehicles. And next, let's talk a little bit about smart car capabilities. We can see grid pricing awareness, type of use, eco modes, tunable regenerative braking, remote control of the vehicle function. So there's a lot of things that you think about your smartphone. There's a lot of things that you can do with a smartphone that you couldn't do with, your older typical flip phone. That type of smart car capabilities is starting to happen with the vehicle. You can adjust your braking. You can adjust kind of how the vehicle drives. I can make my vehicle faster or slower by just flipping a switch on here. And I can make it more energy efficient or less energy efficient, depending on how I want to drive the vehicle. And these upgrades are actually done quite frequently through over-the-air updates, just like you would download the latest software version on your phone for a new operating system, that sort of thing. You can do that with your vehicle. Your vehicle will just download it, and the next day you may end up having a vehicle that's a little bit different, or hopefully a little bit better than it was the night before. And a lot of times these vehicles do get better and better year over year, even though it's the same vehicle that you own.
And that's a careful distinction on that first cost parity. Right now, as they've been looking at life cycle cost, electric vehicles on a life cycle basis many times are actually lower than their gasoline counterparts. And so noting that first cost parity by 2025 is looking at the sticker price on the lot. We had covered earlier that you're going to save every day after you buy it. But by 2025, when you walk onto the lot and you say, okay, would you like the gas version for $30,000, or would you like the electric version for $30,000? And so you say, okay, now that it's the same price, even up front, because we understand that many decisions are made based on the purchase price and not the ongoing price. So yes, 2025, that's just a few years away.
Absolutely. As we look at some of the other benefits with electric vehicles, you have a very high level of diversity with electricity generation, and that can actually help reduce price volatility. So if one way to produce electricity becomes too expensive, we can look at other ways to produce electricity. And that's why you typically look at the cost of electricity year over year. It changes, certainly, but it usually doesn't change that much. If you were to look at the cost of electricity over 10 years, it's going to be pretty similar to what it looked like, from the year before. Of course, there are some price increases, and some years it's more than others. But if you compare that to kind of the price volatility with oil and gas, you're going to see more price volatility with oil and gas. Now we'll talk about how the transition to electric vehicles can benefit property owners. So if I'm a property owner, why would I want to add a charge station to my property? That's kind of the question that we're looking to answer here, if you will. So property owner first can recover some of the fees and some of the costs by charging a fee for the electricity itself. So that's one thing just to consider. Sometimes people worry that they're not going to be able to recover the costs. Well, it is something that can be recovered. And then there's also this potential for future backup power source for essential services. Although this is just being talked about right now. Don't want to get ahead of ourselves. This is something that people are thinking about, and it is something that might be available in the future. There's also the opportunity to share electric vehicle charge stations among several cars, so you can kind of stretch that investment, and that could be through power share, or it could be by installing one charge station that has a long enough cord that 2 or 3 or 4 vehicles can actually charge off of that. We'll show that in one of the case studies shortly. This can also attract and retain tenants. So let's just say you have a rental property. Maybe this would be something that would be attractive to somebody that might be looking to rent in that building. If I have an electric vehicle, I'm probably going to want to rent a place in a building that has a charge station. And the same is true if I'm picking a garage to park my car in near the office. And then finally, 20% of Americans say that they are likely to buy an electric vehicle for their next car. So these vehicles are becoming more popular, and you can actually see kind of the chart at the bottom here show the growth of electric vehicles and where it's anticipated to go in the years ahead. Now we'll talk a little bit about applications. So once charge station is installed, there are several applications that this can be listed on. So a few of the things that you might want to think about if you are thinking about putting in charge station or listing this on some applications. Are there different ways to accept different payment methods, and is that important to you? So if you're a residential building, perhaps one option is enough. So if you have building that you've got the same people there every day, maybe one payment method's enough. Whereas if you're at maybe a retail location, you might want more options. You might want to be able to accept an RFID card or a credit card. You may want more options. Is the price visible and flexible? So some charge stations host many, they want like different rates for different user groups. So we've seen where a charge station is installed and they have one rate for people that work in that building and maybe a different rate for anyone else visiting that site. Also, the next question might be, is there in-app payments? So one of the things I love is being able to pull up to a charge station and plug my car in. I know that all the information's already in the system and it'll just recognize my car and immediately kind of make the payment. I don't have to get out and swipe a credit card or anything like that. That is another piece that some people do like. And then are there cross-platform payment options so that way you can align with several systems? Can you select a charge station and navigate there? So a lot of times when I'm traveling somewhere and I've selected a charge station, I can just click on it. It'll automatically load into my navigation system and I'll know exactly how to get there and where it is. And then also, can you reserve the charge station in advance so that way when you get to that location, maybe it's a hotel that you can plug in and charge and that you'll be the only one that has that charge station reserved for that time. Next, we want to jump into some case studies. So the first case study that I want to dive into is a project that I had the opportunity to work on. It was with Lake County. It was about 5 years ago. So this is actually an older case study, but it actually, I think it's still relevant to today. So, we were able to install two dual port chargers. So that basically meant that there were 4 ports that could charge 4 vehicles at once. And then Lake County purchased 3 electric vehicles to put into a fleet. And this was to be used for employees to drive to and from meetings. One of the things that we did was we hosted a training session so that way we explained it to everyone. Everyone knew how to use these charge stations, how to use the vehicles as well. And it really helped when they put these vehicles into the fleet. People immediately knew how to use them. They immediately knew how to charge them. And in fact, these vehicles were actually some of the most used vehicles in the fleet. If somebody was taking a vehicle out, and as long as if they weren't going too far, these were the vehicles that were typically selected. One of the key takeaways from this is that when Lake County put these into their fleet, they didn't just allow these charge stations to be used for the fleet vehicles, but they also allowed them to be used for workplace charging and for people that were visiting. They had different rates for everybody, but one of the key takeaways is if you are putting in these charge stations and you want them to be more utilized, it's really nice if you can open it up to multiple different users. So even if you're thinking about putting this in a residential building, maybe guests that are visiting that building can also charge on there. They may have to pay a fee, but that is something that really proved beneficial with this Lake County project. The next case study, we'll talk about Northwestern Medical Center. A community group requested that a charge station was put into a garage that they were building. Northwestern decided to put the charge station into this new construction. These chargers are available for workplace charging and also for visitors. And the station was listed on multiple different websites, so that way people could recognize this charge station, whether they were going to PlugShare or the alternative fuel vehicle website. So this was a really interesting project, mainly because, and I would say the key takeaway from this would be, it really was an opportunity where Northwestern was able to work with this community group, and it also showed this community group that Northwestern was really doing some things that they were being asked to do. So it worked because it engaged this business that was in the community with that community. This next slide here is the garage. It was actually a new building that was built in Lakeview. Within the garage, they decided to install some charge stations. Now, these are actually not level 2 charge stations. These are urban fast chargers. They charge vehicles probably closer to 200 to 300 miles of range for every hour that you're plugged in. They're called the Tesla urban chargers. And this is an example of where a building outsourced the charge stations, and these garages are used not just for grocery shopping, but also for a gym, for a bank, for a coffee shop, and a number of different services there. So this is an example where, the kind of key takeaway from this is an example where even if you have a building that you think you don't necessarily want to own and manage the charge stations, you can look for these outside partners that you can work with, you can kind of partner with to manage those charge stations for you. And then this next slide here is a residential building retrofit. This building is a building it's a high-rise building that's on North Lakeshore Drive. This was actually a retrofit where a charge station was added. And you can actually see in here the cost for the charge station. So it was about $3,800 for the charger and the installation. But one of the things, and then the building charged monthly fees, which would both recoup the electricity for the vehicles that we're charging, as well as the installation costs. One of the things that you'll notice here in this picture, you can see 3 electric vehicles. All 3 of these vehicles share this one charge station. And even if, and you can actually see, even if all 3 of these vehicles were parked, you can stretch that cord. It was long enough that it could hit all 3 of these parking spaces. In fact, there's probably about 4 parking spaces that cord could reach to, potentially more, but I would say 4 would be the minimum. Next project, this is from about 2015, so it's about 5 years ago. This was an interesting project because one resident was interested in installing a charge station. The building decided to conduct a survey to see if anyone else was interested, and there were actually seven other residents that were interested in doing this as well. These were dedicated parking spaces, so everyone owned their own parking space. So this was not necessarily an opportunity to kind of share charge stations, but what they were able to do is kind of share in the infrastructure costs. So instead of, if you were to install one charge station, as we saw in the example before, it would have been about $3,000 to $4,000 to install that charge station. This project, because there were so many individuals that were able to do it, the cost came down considerably. It ended up being about $1,500. So kind of the key takeaway on this is, if there are ways to leverage more than one charge station being installed, it might be advisable to try to see if more than one person would want a charge station in that parking space. And then the last case study here that we have for today is in the Aqua Building, which is downtown. This is a residential and hotel near Millennium Park, residential building, and it also has a hotel in it. It's near Millennium Park. And in this case, Tesla installed and manages urban chargers at this site. So again, the key takeaway on this is in this building, you have multiple different users there. It's not just retail. It's not just residential. It's not just a hotel. It actually has multiple different users that, you know, are all in this building, and they were able to kind of work together to put in this charge station that multiple users could use. So on this note, I will turn it back over to Ryan to finish the presentation.
Thank you, Brian. With that, let's go ahead and put another poll here. Launch another poll, and we'll get to a few more questions here. So as far as our poll, we've got a couple of questions here. Which of the following are benefits from the transition to electric vehicles? New revenue source for building owners, higher maintenance costs, lower cost of ownership, easier parking, and increased fuel flexibility. That one, you should be able to choose more than one. And then the other one, which is when would someone want to charge their vehicle to minimize the cost? Overnight, middle of the day, whenever they get home. Which, speaking of cost, we did have several questions come up as far as, you know, what's the cost to charge a vehicle? And again, this can depend based on, you know, how far you drove and the efficiency and the cost of electricity. But just as an example, someone had given a good example as far as, you know, we're used to, you know, you drive so far and then you fill up. And so in this case, they looked at and said, okay, a 16-gallon tank at just under $3 a gallon comes out to just over $45. And so for an electric vehicle, if I wanted to drive it, say 400 miles before I charged it, that would take somewhere on the order of 100 kilowatt hours. So if I'm paying 10 cents a kilowatt hour to drive 400 miles, which is about equivalent of a 16-gallon tank, it would cost me about $10. So that's a dramatic difference between $45 to drive 400 miles versus $10. So, and the cost to charge can depend fairly dramatically as far as some stations charge by the minute and some charge by the kilowatt hour. So figuring, you know, 20 cents per kilowatt hour might be what you might pay reasonably at a remote charger. So at a private charger, you might pay something like that. Which even at 20 cents a mile, that's still only $20 for 100 kilowatt hours. So question here, and Brian, I'm not sure if you would know, typical battery life of an EV. As I recall, they've been finding that they've been lasting longer than they were originally anticipated. I'm not sure, Brian, if you have any more information as far as battery life.
That's a great question. So battery life, certainly, you know, we're certainly getting a lot more information on that. One of the groups that I've done some work with is a company out of Shenzhen, China, which is BYD, and they actually have they have some of the vehicles that have higher mileage applications because they run a lot of taxis that are electric vehicles, which drive a lot of miles. We're talking 70,000, 80,000 miles a year. So they started retiring some of their taxis, not because the batteries were going bad, but because the wheels were falling off, basically. And they were pushing out over 500,000 miles on them. So, you know, I think that you do have a lot of batteries that are looking at, you know, 300,000 to 500,000 miles as typical battery life, but there is a big push with new batteries to be trying to reach that 1 million mile battery.
Yeah. And similarly, the cost of batteries continues to decrease too, and so that may be something else where if you were to you know, price a new Nissan Leaf battery today, If you say, okay, if I bought a car today, what would it cost to replace the battery today? That cost may be dramatically different. You know, if you put, you know, 300, 400,000 miles on a vehicle, which, you know, a lot of people, you know, they'll get rid of a vehicle long before it gets to 300 or 400,000 miles. So it's interesting that you're finding that very long life of those batteries.
Yes. And just another point on that. So Rocky Mountain Institute, I'd worked with them a little while back on analysis for taxi fleets and ride-sharing fleets, and they would typically model the internal combustion engine vehicle to last for 200,000 to 300,000 miles. Again, they were using 500,000 miles for the electric vehicle, so nearly double the number of miles that could go onto an electric vehicle versus an internal combustion engine vehicle. Fewer moving parts also benefits the electric vehicle beyond the battery itself. So the motor, electric motors are last for a long time.
Here's a good question. As far as if there's chargers that have multiple cars connected, can they automatically rotate who is charging during low demand hours? And that may depend on the different chargers that are available. Some power sharing chargers may rotate who is charging. Others, I know, Brian, you had the experience where your work charger, it's, you know, based roughly 40 miles divided by however many people are charging. So it just ramps down and ramps up based on how many people are charging. So yeah, there may be chargers out there that do rotate through and say, okay, you get 40 miles of charge, okay, you get 40 miles of charge, you get 40 miles of charge. And others just say, okay, you each can have 10 and we'll move on from there. So that's an excellent thing to consider when looking at different chargers and saying, how do they handle that power sharing? Here's someone that noted, there again, looks like they're probably charging at home, but they noted for them, it costs them about a penny a mile to drive, and they're just over 400,000 miles on their battery. So very, very good that we're seeing that good long life. Move away from questions. We'll come back to that before too long here. But as far as our polls, so benefits of transitioning, new revenue source of building owners, check. Higher maintenance costs, good. No one picked that one. Lower cost of ownership, check. We got that. No one is under the illusion that this will make parking in Chicago any easier. And increased fuel flexibility. So yeah, pretty much most people got all three of those. That's good to see. And when to charge your vehicle? Overnight. Yep, that is the time to save. So yeah, that's very good. So picked up on people. So now that people are getting where they're EV ready and you know they're excited about electric vehicles. Now let's take a look at next steps. Now that you're EV ready, how do we move to EV installed? And this is provided by City of Chicago. They've got a good little site as far as here's the steps you need to go through as far as making that transition from EV ready to EV installed. You know, yeah, for building managers, as Brian had noted earlier, you know, identifying how many chargers do you need, particularly if you're retrofitting. It's much more cost effective to do more than one than to just do them, you know, one at a time. So there may be some rebates out there. Previously, I know the state of Illinois had some rebates for electric vehicle installation or charge infrastructure installation. I believe those have expired. Utilities may have some rebates, and even if they don't today, they may tomorrow. So make sure you identify if there's any rebates to help offset some of this cost. And then getting your permits and getting things installed. So this is kind of a steps from City of Chicago. And then, overall, once you've installed your charger, you've gone through those steps and gotten it installed. So, once you've installed your charger, then going through and doing your markings, that could be anything from something fairly simple to just that little sign there on the right as far as electric vehicle parking, to something that's perhaps a little more extravagant and public facing as far as the photo there, where you can definitely tell that there is something about these parking spaces that's different. So then dealing with setting up your fee structure, are you going to charge by the kilowatt hour or by the hour? Some even break it down by the minute. And then if you want to have these be public facing, going ahead and listing those onto some various platforms. There's a few examples here, whether that's the DOE Alternative Fuels Data Center, some of the various applications, the charger platform. If you use some of the larger charging platforms, they may have their own platform and interface, so you can use those, and many, many more. There's a lot of variation that's out there as far as what you can do with electric vehicles. But I think most everyone will agree that electric vehicles are coming, whether we think about it or not. With that, we do have a few more questions that have come in. Yeah, I do have a question here as far as how much a public charger costs, as far as the actual purchase of a public charger. That can depend, particularly if you're looking at one of those DC fast chargers. Those can get rather pricey. I don't have any costs on that. But as Brian kind of talked about, you don't necessarily have to spend a lot of money to have a public charger. Yeah, and that's where these network chargers can come in handy, where through some of these different applications, EV Match and a few others, you can take just a regular interconnected charger, or a regular networkable charger, and enable it for payment processing, and really turn it into a public option without a lot of cost involved. So yeah, the DC fast chargers could get kind of pricey though.
Yeah, and Brian, I might just jump in here just to provide a few more items on that. But when you think about a public charger can run quite a gamut, if you will. So if you're just looking at a public charger as a simple charger, you just want to be able to allow somebody to plug in. There's a lot of chargers that are not necessarily Wi-Fi connected that can be a few $100s. Maybe $300 to $500 is a pretty reasonable public charger. In fact, the charge station at my workplace I know for a fact that one was $500, or at least that's what it retails for, because it's the same one that I have at my home. So that is and that's even a Wi-Fi connected charger. I will say that we also had the charge station that we had at my old building that was shared among multiple people. That again was a Wi-Fi connected charger. It was an Energy Star rated charger, and that was about $800. So again, kind of on the simple side of things. But then you do see some chargers that accept credit cards, have screens on them, and those can run a few $1,000s. So depends on the level of sophistication that you want in that charge station. You can probably see anywhere from $300 to probably a few $1,000s, depending on what you want in that charge station.
A few more questions. Another question about if there's any metering requirements for chargeback to EV owners. There's nothing that requires that. That is certainly an option for building owners. And again, some of this depends on what your particular infrastructure looks like. Some of these, some of the case studies that Brian had talked about, some locations they look at and say the cost to meter it would be likely fairly high, and so we're just going to charge everyone a flat rate that's an EV, any EV owners in our building. We're going to charge you, whatever, $50 or $100 or $300 a month, and that includes all the electricity that you might consume through the charger too, rather than paying for the metering to have that. So, but yeah, so there's nothing that requires it. And again, someone else had made a note as far as it was interesting that the code was only requiring level 2 charging, and I think a lot of that goes back to that's where the vast majority of the charging is going to occur. DC fast charging tends to be a little bit harder on batteries than a little bit slower charging, and also understanding that that's more designed for road trips where I got to drive more than 200, 300 miles at a stretch. Now with electric vehicles having ranges of 2, 3, 4, 500 miles, the need for DC fast charging is definitely going to be reduced for a lot of those. Let's see here. Yeah, there's an interesting question here as far as, and Brian, you might have some thoughts on this, as far as what might occur with electricity prices if we end up where half the vehicles are electric.
Great question. So there's actually some good studies out there as more vehicles become electric. What we should see is if we do encourage people to charge more at night, what you're basically doing is you're seeing that electric vehicles can actually have a positive impact on price. We would think the opposite would occur because there's more demand, but that demand, if managed correctly, if everyone starts charging, late at night when there's excess capacity on the grid already, then you are actually able to sell that electricity that would normally not be sold, and you're able to increase revenue while not increasing expenses at the same level. So there's a few different studies out there that show that if we are able to ensure that people are charging at night, then we should be able to reduce costs. Now, on the flip side of that, if everyone comes home at 5 p.m., plugs in their vehicle and charges at that same time, then it could have a negative impact on electricity prices. So it's really important for us to, approach this in a smart fashion. And I think that there is a lot of talk about that throughout the state, and people are looking at ways to make sure that people are charging during these off-peak demand times.
Yeah, and that's a good thing to consider as far as some of these smarter chargers. Are they becoming a little bit more grid aware as far as some of these pricing signals and saying, not that we want, we don't want the inverse where all of a sudden everyone charges at 3 o'clock in the morning, but saying, okay, some people, okay, you're going to charge at 1 o'clock and you're at 1:15 and you're at 2 o'clock, and being able to manage this load, and similarly, having the ability to basically kick the loads off the grid if there's an unexpected disruption or something where all of a sudden, hey guys, electric vehicles, I'm running low on capacity. Can you guys just hang on for 5 minutes and just pause your charge for a bit, and being able to manage and dispatch a lot of that load. Here's a good question for you, Brian. As an electric vehicle user, how much range degradation do you see during winter?
Oh, that's a great question. So with my vehicle, there's, typically you'll see maybe 15 or 20%, and this is just kind of from personal experience. I'm sure there's some studies out there that are more scientific as far as the exacts, but usually I'll see maybe 15 or 20% on the really cold winter days. I could see about a third of my range drop, and I've taken road trips driving through the middle of blizzards with my electric vehicle. Been up in Wisconsin, driving through quite a bit of snow, a lot of cold weather, and that's when I'll see kind of that. I can see a third of my range kind of come off. So if I have 300 miles of range, I might be really considering it to only be 200 miles of range because of the impact with cold weather. With that being said, and that's with kind of today's electric vehicles, we are seeing more and more of these vehicles come out with systems that have, say, heat pumps in them and other ways to help to make sure that there's less of an impact on range in the cold weather. So again, that's like the Tesla Model Y has that, and a few other vehicles are starting to come out with that I think will have benefit us in the winter.
Good. Do you know if vehicles other than Teslas are able to use the Tesla urban chargers?
Great question as well. So Tesla does have their own proprietary charging system. So Tesla does this, BYD does this, and that's actually not just with their urban chargers. That's also with their level 2 chargers. So other vehicles cannot charge on there. I have seen other vehicles use kind of an adapter to charge from a level 2 Tesla charger into a J1772 port, but I have not seen that with their fast chargers, whether it be their urban chargers or their any of their other chargers that they have available that are fast chargers.
Yeah, and looks like we've gotten several questions about that. I believe that most everyone, at least in the U.S., other than Tesla, has kind of settled on that SAE certified J1772. I think that's the number 1772 charger.
It is.
Charge port.
So yeah, and just to, I was going to say, Ryan, just to kind of expand on that, sorry to interrupt, but as you're talking about the J1772, that is kind of that standard that is used here in the U.S., and it is something that even if somebody were to have a Tesla vehicle, they do have adapters that can charge off of that. So J1772 is from a level 2 perspective, what is kind of the standard, and it is what pretty much everyone can charge off of. Whether I know that Tesla may have their own kind of proprietary chargers, but that being said, Tesla can charge off of that J1772, no different than a Nissan Leaf or really any other electric vehicle can.
Good. I have a question here about after November 1st, if applying for a permit for a 3-unit or 4-unit residential with a parking area, do you need to build EVSE? And EVSE for City of Chicago, as I believe we stated earlier, begins with 5 residential units. So once you have at least 5 dwelling units and on-site parking, that's when EVSE infrastructure is required. There is nothing that prohibits it from being installed for smaller units, either fewer than 5 for residential or fewer than 30 parking spaces for commercial. And kind of as we touched on today, anytime you're doing new construction, putting some infrastructure in the ground is it is low-cost insurance for you into the future, because retrofitting these later can be definitely much more expensive. Had a question as far as the PowerPoint and the presentation being made available. Yes, the recording of today's presentation along with the PowerPoint or a PDF will be available at our website, sedac.org. So yes, please do make sure to feel free to pass this along. As far as ComEd's involvement with charging customers, let's see here, ComEd not allowing building owners to resell power. Yeah. Building owners collecting fees and passing that on. I'm not totally sure as far as all the ComEd's rules and regulations and how that is. Again, that may be on a much smaller scale than we may be dealing with here.
Brian, I can jump in that if somebody were to install a charge station, they are able to charge for that electricity. They can do it on a per kilowatt hour, or they can do it on an hourly basis as well. In some states, they're not allowed to charge on a per kilowatt hour basis, so they have to do it per hour. So in Illinois, we're able to do either.
Okay, that's good. Let's see here. Battery disposal for EVs. Do you have any insight as far as that goes? You know, and I realize again, kind of like all the battery technology, what's available today and what's available 5 years from now is likely to be very different.
Yeah, so a couple quick notes on battery disposal. So I think typically we'd work with the OEM on that. There is actually a high level of discussion surrounding battery recycling. So I know Argonne has a new group called Resell. They are actually working to find the best ways to recycle the batteries when they're done. And actually there's another question on R&D happening with solar charging stations, and there's actually Argonne's doing a lot of work in that space as well. In fact, Argonne Labs has solar charging stations that are set up, and they're actually looking at interconnections with the grid and a lot of different research projects to really determine how to integrate electric vehicles as more and more come on the market.
Here's a question as far as potential to reduce the quantity that the code requires of EV chargers if level 3 are provided instead of level 2. That is not presently in the code. That's not to say that couldn't occur in the future. Again, I think the objective behind these codes and ordinances is for long-term use of parking spaces, not people that just pop in to grab a quick charge, because that's one that I think as Brian kind of alluded to in the case study where one EV is shared, or a charger is shared across EVs, is you have to be able to, if you're doing it that way, then you have to be able to move the plug from one to another. And so most vehicle charging is not designed where, I pull into the garage, stop off at the fuel station, get my electrons, and then go park the car. So that's not to say that couldn't happen, but that's not the way they're written right now. We didn't touch too much on vehicle to grid. We've gotten a couple of questions on that as far as being able to utilize the EV as a backup power source. We didn't get too much into that. And there again, that's one that could be a rabbit hole all by itself in a presentation all by itself on vehicle to grid technologies and what's coming up. But we definitely see where particularly as kind of as we had alluded to earlier for grid support, being able to have the grid borrow some of those electrons back out of the battery during those peak times. So, because it does seem to be transmission and distribution is where the grid really gets stressed, and so, you know, having a whole bunch of electrons sitting inside of a building that could be dispatched could be very useful on that. And yeah, similarly for electricity utilities, yeah, several of them have some controllers to disconnect AC units during times of high demand. Could definitely see that in the future for electric vehicles.
Yeah, just to kind of talk a little bit about kind of you know, the ability to control chargers with, you know, kind of like you do with an AC switch. That's part of the whole managed charging piece. Lot of the discussions more about, you know, charging different rates at different times, and, you know, even if a vehicle is charging on a universal charger, maybe there's some telematics that can be used for that. But I do think that there is a lot of talk about how do you really encourage people to charge during those off-peak demand times, or potentially at least not charge during the highest peak demand times, kind of like you were mentioning with that, you know, the AC cycling that occurs now.
Yeah, I think we got one or two last questions here. We'll go ahead and answer, but I realize we're at our hour and a half, so I do want to thank all the people who joined us today. And again, if you do have any questions about the energy code, feel free to reach out at energycode@sedac.org, or feel free to give us a call at our 800 number. But we'll go ahead and answer these last couple of questions here. As far as public parking garages embracing electric charging stations, I don't know if you've seen any around the city of Chicago where they've really embraced it, or has it just been kind of a niche thing so far?
So throughout the city of Chicago, we have actually seen quite a few charge stations being installed. So the parking garage that we park at work has over 10 charging stations. There's a lot of other garages may have, you know, 2 charging stations. So we do see it quite frequently. If you actually go to PlugShare or one of those types of apps, you'll typically see quite a few, at least in downtown Chicago, and then you'll see them sporadically throughout different neighborhoods. And some charge for electric. Everyone has a different approach. Some charge for electricity. Some may give you the electricity free, but you might be paying a fee to park in that parking garage. There's a number of different approaches that we've seen different garages take.
I am not aware of any, but do you know if there's any tax credit for electric vehicles at the moment for Illinois?
I'm not aware of any at this point either. I do not believe so right now.
Just the federal tax credit at the moment. All right. Again, want to thank everyone for joining us today. Again, feel free to reach out if you have any other questions. Again, have a great day.